Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and today I want to finish up my review of the general science test that I gave the science denial group over at the asylum the other day. Today we're going to pick up where we left off, and that is with physics questions. So, let's have a listen to the first one. Is buoyancy a force? Is weight a force? Now, they did well with these questions. They seemed to come to the consensus that both buoyancy and weight were forces in the Newtonian sense. It's a verifiable fact that air pressure decreases with increased altitude. At what point does air pressure stop decreasing with increased altitude, and why? Now, this question caused them some problems, and this is the result of an error in reasoning, characteristic number 4 of science denial. Now, while they agree that air pressure decreases with altitude because it's a verifiable fact, their idea of why that occurs is rather strange.
I would say roughly around 100 kilometers. That's what it's stated. And why is because gases are formed from the earth, not from the sky.
I don't know. I've never measured it.
Well, you can say that too, but I'm just going along with the, globe motto.
So your answer
So if we
is
repeat their
100
story,
kilometers.
Roughly.
Okay.
That's just a rough
And
guess.
why? Gases are
Because that's where
formed from the earth was your answer. I don't think that
Yeah.
actually answered the question that was asked.
carbon dioxide comes
Where-
from trees, right?
The air pressure decreases with altitude.
Okay.
At what point, as in pressure, does that air pressure stop decreasing? Let me make sure that that's very clear. I'm specifically talking about the air pressure itself. When does it stop decreasing and why?
That's around 100 kilometers. The carbon line.
And what's the pressure
According
there?
to the heliocentric model.
And what is the pressure there?
lesser than the ones below.
What is the pressure at the Kármán line at 100 kilometers? What is the air pressure?
We can Google it. Do you want a Google answer?
No, I just want you to tell me it goes
Well,
down
how would
to
we
a
know if
certain,
we've never measured it?
It goes down to a certain value and then it stops going down anymore from there. So what is that certain value?
All right, Google it, Don. Because no one here has measured any of that, so we're just going to have to.
The Google answer is 3.2 times 10 to the negative 2 exponent pascals, I believe, is PA.
Okay. What makes it stop decreasing there?
Because gases are coming from the earth, not from the sky.
Okay.
That's why.
All right.
They're formed from the earth. Carbon dioxide comes from plants, not from the sky.
Okay, well, we have a couple of issues with this problem, and that is this. Air pressure decreases with increasing altitude. The question was, at what point, pressure-wise, does it stop decreasing and why? So, for example, what's the minimum pressure in the atmosphere? That's what I was getting at. And their answers, while they did acknowledge the fact that the air pressure does go down, their thoughts of why that occurred were rather bizarre. For example, they thought that it had to do with carbon dioxide from plants. Now, plants do indeed release carbon dioxide at night in the absence of sunlight. The product of photosynthesis is oxygen, not carbon dioxide. Carbon dioxide is taken in with water, and the byproduct is oxygen and sugar. Now, another problem that they run into with this line of thought is that they have to understand what the concept of a balanced equation in chemistry is. For example, you have to have 6 moles of carbon dioxide to get 6 moles of oxygen. In other words, there is a 1-to-1 exchange, so there is no net gain of gas from plant photosynthesis or respiration for that matter. The only gain that we get for gas is release of carbon dioxide from carbon dioxide ice in the bottom of the oceans and from volcanic eruptions. There are some other minor sources, but those are probably the 2 biggest ones. He did say something about the Kármán line. Now, the Kármán line is considered the edge of the atmosphere and space. The interesting thing about the Kármán line is that the pressure continues to go down the further you get away from Earth. There are parts of the Earth's atmosphere that extend out past the moon. The pressure steadily decreases. There's nothing special about the pressure at the Kármán line. Now, what I was actually trying to get at to them with this question was, why would the pressure suddenly stop decreasing? They didn't really answer that question. Now, they were able to Google an answer for the air pressure at the Kármán line. It was given in pascals. I was going to ask him to define what a pascal was, but I just didn't have the heart. Let's move on to the next question. What causes tides? What causes tides? Now, the answer that they gave under the globe model, as they understood it, was that it was the moon and spooky gravity. And then somebody interjected something else that was rather interesting, the shape of the Earth. Let's explore that a little bit.
Its tilt has everything to do with its orbit.
Okay, you're
and
about to
which
get wrecked.
gravitational pull it's most affected by.
Okay, so I've got the moon, spooky gravity, and shape of the Earth are what causes tides. Is that your
Amongst all
answer?
the other flat Earth explanations that,
Is that
I'm
your
sure
answer?
you're not looking for. Those are three variables, absolutely, in your model.
Now, I found it very interesting that they felt the need to include the shape of the Earth and the tilt of the Earth in the cause of tides. I tried to press them on that, but they couldn't really give a reason that they said those things. They just said them. So they didn't really answer that. Now, obviously, the moon and the sun and gravitational forces cause the tides. The shape of the land masses, for example, wide expanses of ocean versus narrow bays like Fundy Bay in Newfoundland, have to do with the size and the magnitude of the tides. Any body of water, and for that matter, land as well, demonstrates tidal forces acting upon it. Even in the Great Lakes, we have 10-centimeter tides in Lake Michigan. Now, this is just a lack of understanding of the origin of tides. This is something that many of us are taught, and I've put out several videos on it. I doubt they've seen any of them. I'll give them partial credit for mentioning the moon and gravity, but they definitely had no idea what they were talking about with the tilt of the Earth, and they really don't understand what causes tides at all. Name 3 ways that we can measure the radius of the Earth ourselves. Now, this question utterly baffled them. From flat Earth circles, they have heard about Eratosthenes measuring the shadow, and they've heard about Al-Biruni, which is measuring the dip angle down to the horizon. But they never really seem to have looked into that, and they certainly don't know any other ways of measuring the radius of the Earth. I recently put out a video where I demonstrated 5 different ways. I did the geometry of the ancient Greeks, Eratosthenes, Al-Biruni, great circle distances, and Kepler's laws using the orbit of the moon and the ISS to determine the radius of the Earth. Any of these answers or anything else reasonable would have been acceptable. But what they did was they simply parroted back the first 2 because they had heard those on flat Earth channels. They don't understand what they are, and they couldn't explain it in any way. But at least I'll give them credit for 2 out of 3. But the real question was, do they think outside the box, and have they ever looked into this? They haven't. Now, one thing that we've seen so far in this test is errors in logical thinking and unrealistic expectations of science are 2 of the big things. For example, with the atmosphere, their take-home answer was, well, we've never been there to personally measure it, so nobody knows. Well, that's not true, because then they turned right around and Googled the correct answer. When they talked about Al-Biruni and Eratosthenes, I pressed them for the 3rd way to measure the radius of the Earth. Have a listen to what they said.
The moon,
Well,
right?
according to Al-Biruni, you can just look at it, I think.
Yeah, pretty
The
much.
horizon.
Are
Okay,
you
so
sticks?
Al-Biruni is one.
Eratosthenes using sticks and shadows.
Hold on. Bob, I really want your audience to know that we're not saying these are how you can do it. And I hope you don't misrepresent us by saying that here's how you can do it.
No, I'm asking how you think The globe says we can do it ourselves. So you've
Well-
got Alberuni and you have Eratosthenes. The
Well,
question
Alberuni
was-
wouldn't be us doing it ourselves.
the question would be 3. So what's your third way of doing it?
GPS. I don't know.
The moon phases.
How do the moon phases tell you?
Don, shut up, Don. What the hell?
Okay, well, I'm still waiting on your third answer. So what's the third answer? What is the third
we
way
could-
that
we
you
could
can
make
measure
it
the
up.
radius yourself?
We could lie.
You're welcome to.
Yeah, well, that's what we would do. So there's 3 ways to measure the radius. Looking at a horizon and saying something. Lying about it, and what's the other one?
Honest to God, they couldn't even remember the first one, Eratosthenes. They seem to think that these values are made up and they're stories that are being told. They also seem to be under the impression that you couldn't do Alberuni's experiment. Obviously, by saying Alberuni, we're talking about the method Alberuni, not bringing Alberuni back from the dead and having him verify that he actually did it. But I find it very interesting that they would put lying about it as their third method. They have absolutely no clue how to do this. They've never looked into it. They can't even really tell me what the method Alberuni is, much less the Eratosthenes method. And that would include how it works and the drawbacks and advantages of it. I'm going to have to say that they really don't have any idea how to measure the radius of the Earth because they've never looked into it. They repeat things that they hear on flat Earth channels about Alberuni and Eratosthenes, but take them out of that comfort zone and they're lost. Now, to bring home that last point, let's play the last section of that answer. They did finally come up with a third possible way of measuring the radius of the Earth. Have a listen. Remember, they've already talked about Alberuni and Eratosthenes.
The third way is computing it,
With
right?
what?
The third way is computing it.
With what? What are you
With-
using to compute it? Alberuni and Eratosthenes are also computations, so saying computing it doesn't add a third way. I need a third way before we move on.
All right. Yep. Nope.
If 2 bowling balls touch each other at one point, do they share a tangent?
Yes.
That's an affirmative.
Now, this is a very telling question, and that's why I asked it. One of the big things that's going around in the flat Earth right now is that trigonometry is the study of triangles exclusively. You can't have a triangle on a sphere. You can draw a triangle inside of a circle was the answer that we got in the last episode. But I find it very telling that you can use a trigonometric function like tangent on a sphere, and they seem to know that very well. This is a common problem in the science-denying community. They know that 2 bowling balls just touching each other will share a common tangent line. However, they don't make the connection that a tangent is a trigonometric function. And as a result of that, they'll continue to parrot on that trigonometry involves triangles. Well, it doesn't necessarily involve triangles. We just did trigonometry on 2 spherical objects. If you're trying to overturn the current paradigm, you should know the very basics of the science that established that paradigm. Now, I'm going to finish up with this last question because I think this is very telling of the science denial community. The next question is a very simple question. What is a nautical mile? How is a nautical mile determined? This is the Wikipedia page for Nautical Mile. Now, the reason that I'm putting this up is one person actually cited this page, and I want to make sure that we see the exact same page that he was looking at when he cited it. Now, I'm going to get out of here, and I'm going to let you have a look at this real quick because I want to point a couple of things out. Here is the very first paragraph right here. A nautical mile is a unit of length used in air, marine, and space navigation and for the definition of territorial waters. Historically, it was defined as the meridian arc length corresponding to 1 minute or 1/60th of a degree of latitude. Today, the International Nautical Mile is defined as exactly 1852 meters, which is 6,076 feet, or 1.15 miles. The derived speed is that of the knot, 1 nautical mile per hour. Now notice that this diagram right here gives the distance of a nautical mile and notes that it is 1/60th of a degree. Now, I'm going to go ahead and give them the question and then listen to their answers. Knowing that that is what the Wikipedia page says, notice that it gives 3 specific things in that first paragraph: its length, where it came from, and what it's used for. I want you to pay close attention to the answer that's given. What's a nautical mile?
Measurement based on the Earth being a ball.
I need specifics. What is a nautical mile?
It's going to be based on, what is it, latitude or longitude?
You're the one taking the test. I'm giving it.
Which kind of presupposes one of the models, I'll say.
What is the definition of a nautical mile?
Wikipedia. The nautical mile is a unit of length used in air, marine, and space navigation for the definition of territorial waters. There you go.
I'm still waiting
Water.
for the definition of a nautical mile. What is the definition of a nautical mile? Not what it's used for.
I just read it.
What's the definition of a nautical mile?
What does "is" mean?
Going once. Going twice.
Distance traveled through water.
Okay, nautical mile is 1852 meters, 6,076 feet, 1.151 miles, and 10 cable.
What, a measurement of
That's the
distance used over the
distance.
ocean or in the space or
That's
in
the
air? That's what a
distance.
nautical
What
mile
is
is.
a nautical mile, though? A nautical
Distance
mile.
traveled
Measurement
through
distance
water.
In the air.
Oversea.
Okay.
That's what I said earlier. That's what the Wikipedia said.
Right.
Right.
It is a
That's
unit of length
Wikipedia.
used in air, marine, and
Okay.
space navigation. Holy crap.
All right.
Yeah, I thought you covered that.
We'll
Yeah.
go
It's
ahead and
not the
go on to next one
definition.
then. Now, here's the point that I'm making with that. We all saw what the Wikipedia page said. It very clearly said that a nautical mile is 1 arc minute of the circumference of the Earth, 1/60th of a degree. They read directly off the wiki page, yet they conveniently left that little bit out, even though it was on the page in the paragraph that they were looking at. This is cherry picking, which is the first characteristic of science denial. And I think it's a good place to go ahead and close this video. So let me give you my final impressions. When you are trying to overcome an accepted current paradigm, you better know your stuff. What I'm seeing here is a serious weakness in basic understanding of science and scientific procedures, terms, and principles. They cannot answer basic questions in science. You see the paranoia coming through. They're taking a test on their knowledge of the globe, but they think that somehow I'm trying to trick them, or that I'm going to put this off as their opinion rather than a test of their understanding of the globe model, which is what it was clearly designed to do. And that was the premise of them taking the test. It was testing their knowledge of the globe. They seem to be able to memorize definitions, but don't understand what the definitions mean. We saw that when Paul was able to properly define the difference between scientific convention and scientific consensus, but when presented with a very clear example, couldn't identify which of the two it was. Now, I went ahead and I went over each of the answers of the test on several earlier videos. The purpose of this video is to kind of go over the results. I was unimpressed with their scientific knowledge of the globe. I was unimpressed with their scientific knowledge, and they clearly don't understand the globe model beyond what they saw in flat earth videos. A good example of that was they knew about Eratosthenes and Al-Biruni, but could not think of another way to look at the radius of the Earth other than lying about it. They seem to think that Al-Biruni and Eratosthenes are just stories that somebody made up. They're not. I've done them. Many people have done them. School children do the Eratosthenes measurement during the equinox. It's kind of like a standard thing you do in middle school. And finally, I was very disappointed in the intellectual honesty of the panel. To sit down and look at the wiki page on what a nautical mile was and deliberately not give the answer that it was 1/60th of a degree or an arc minute of the circumference of the Earth, which is the entire basis of the nautical mile, is intellectually dishonest. By the way, the difference between statute miles and nautical miles is that statute miles can be paced out on land. On the sea, you can't pace out a distance. You have to do it visually. And that was the way they came up to do it. By the way, in case you want to look into it, what was the original basis of a kilometer? So, this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by. Make sure you hit that like and subscribe, and I hope that you enjoyed this test as much as I did. I want to thank the people over on the asylum for agreeing to take part in it. They did a good job. And quite frankly, I think the test was very telling. So until next time, stay well and see you soon.